Okay, our last lesson is we're going to combine these two topics together. So our first half of this unit, we looked at quadratic graphs. Then we looked at quadratic equations for the second half. But there is a connection to them. So if you look at the equation I have below, we have y equals x squared minus x minus 6. So in the last unit when we graphed these things, we got a graph that looked something like that. And then now what we've been looking at is we've been looking at quadratic equations. So if you compare the two, they're both exactly the same thing. The difference is one has a y equals, the other one is equal to 0. So if we use our logic that we know from before, so a graph like this, when y equals 0, that's going to refer to our x-intercepts. Right? That's where the y equals 0 on this graph. So all we have to do to connect the two is figure out where those x-intercepts are. If we can find the x-intercepts, that'll be where y equals 0, and those x-intercepts will then be our solutions. So the x-intercepts are the solutions to the quadratic equation. So the trick is we can actually solve quadratic equations by factoring. We can solve them using the formula, but now probably shorter and easier way is just graph them and figure out what those x-intercepts are. So on the graph, if we were to sketch this one out, we can use Desmos, you can use your calculator, you can use whichever method you want, and we would get, in this case, our x-intercepts would be -2 and 3. So when x is 3, or when x is -2, that's when we get our zeros. That's when we get our values for when y is equal to 0. So our x-intercepts, zeros is also used. Roots, so the roots of the equation, that means the same thing, which basically means solutions. So those are all interchangeable. So all we have to do is graph them, find your x-intercepts. So in this case, our two answers would be -2 and +3. Okay, so it's a pretty easy method, and it doesn't matter how complicated the equation is. Graphing should always work. So let's do one more new one. So let's suppose I give you a complicated question that looks something like that. So we have two choices. We either just make sure it's equal to 0 like we did before. So let's do that for this first part. So we want to get the 9x over, so we'd subtract 9x, and we want to get the 2 over. Okay, so in this case, once we do that, we have 3x squared minus 15x minus 2. So then what we want to do is we want to sketch that on the graph. Okay, so let's use Desmos. I'll quickly do it on Desmos just to see what it looks like. So we have 3x squared minus 15x minus 2. So in this case, we get a graph. Looks kind of like that. So then what we want to do is figure out what those x-intercepts are. So the first one is at -0.13. And our second one is at 5.13. So if we were to use the quadratic formula, this would be the case where you'd have a square root of a number. So you'd have something plus or minus a square root divided by whatever, and that would give you the two answers. In terms of the graph, it'll always just give you a decimal answer. We won't get square roots, but that's okay. As long as we don't, doesn't matter. We can just find those two x-intercepts as decimals, and that's it. I just want to show you one other option. So in this case, we made the equation equal to 0. Another option is you can just leave it as two separate equations. So do y equals 3x squared minus 6, and then graph y equals 9x plus 2.
Mr. Hensing, will you please come to the Learning Center to be assistant with Anne Fox?